the oxygen acts as the final electron acceptor in the ETC. During oxidative phosphorylation, the electron acts as the oxygen acts as the final electron acceptor in the ETC. And so it allows the electron to keep on flowing. It allows regeneration of oxidized nitrogen fat. It picks up the protons from the matrix to maintain a gradient between intermembrane space and the matrix, and it's reduced into water. Later, in case of absence of oxygen, the electron stops flowing in the ETC because all the electron acceptors of the ETC will remain reduced. And so, NAD and FAD remain reduced. And that's why the link reaction and the Krebs cycle are going to stop. At the same time, there won't be a steep proton gradient between the intermembrane space and the matrix, so the ATP sensate will stop rotating, and ATP by chemiosmosis will not be made. The only thing that's going to happen is glycolysis, which takes place in the cytoplasm. Glycolysis will occur, and it's going to make the pyruvate. And during the process, it's going to produce 2 reduced NADs and a net of 2 ATP molecules, and this is per 1 glucose molecule. And this is the only energy which is going to be available for the use of the cell in case of absence of oxygen. 2 ATP molecules per 1 glucose molecule. But still, if we cannot regenerate oxidized NAD, glycolysis will also stop. That even these 2 ATP molecules will not be available. And that's why the pyruvate will enter either one of the 2 anaerobic pathways. It either takes the ethanol pathway or the lactate pathway. So it's either alcohol fermentation or lactate fermentation. The ethanol pathway, this takes place in yeast and plant cells in presence of alcohol dehydrogenase enzyme. The pyruvate is first going to be decarboxylated, which means it's going to lose a carbon dioxide, and it's going to form ethanal. The pyruvate is a 3-carbon, the ethanal is a 2-carbon. And then the ethanal will act as the hydrogen acceptor. It's going to accept the hydrogen from the reduced NAD, and it's going to be reduced into ethanol and allows the formation of oxidized NAD. It allows the regeneration of oxidized NAD. So oxidized NAD is available for glycolysis to continue.
Another like thermodynamical law, what does this
هنا علشان انت 2 pyruvate molecules, it's only 1 pyruvate molecule. هنا it's 2 reduced NADs. Glycolysis بعمل لك 2 pyruvates. هنا this is only one of the pyruvates. So the second one هتعمل regeneration of the oxidized NAD. Okay? In case of the lactate pathway, pyruvate itself will act as the hydrogen acceptor and will be reduced to lactate, allowing the regeneration of oxidized NAD for glycolysis to continue. Lactate takes place, the lactate pathway takes place in muscle cells during severe exercise. When the oxygen demand exceeds the oxygen supply. When the oxygen demand of the muscle cells is more than the oxygen supply to the muscle cells, the muscles have to make more ATP by the lactate pathway. Accumulation of lactate muscle fatigue. That's why this lactate diffuses out of the muscle cells. It's transported to the liver. In the liver, after the exercise, oxygen is used to reoxidize this lactate. Oxygen in the liver is going to oxidize the lactate back to pyruvate, back to glucose stored as glycogen. And this is the oxygen debt. The oxygen debt is the extra amount of oxygen. This is the excess oxygen that we take in after exercise. After severe exercise, we keep on taking more oxygen than usual. This oxygen is the oxygen debt. This oxygen is used to reoxidize the lactate back to pyruvate, to glucose that's stored as glycogen, and to reoxygenate the hemoglobin, and to meet the high metabolic rate of all the organs, because right after the exercise, most of our organs are at a higher metabolic rate than at rest, but they require more oxygen. But this is the oxygen of the oxygen rate. Okay? So this reaction can be reversed in the liver. This reaction is not reversible. ماشي؟ Pyruvate glucose glycogen.
بس محتاجين نعمل ريأكسجينيت للهيموجلوبين وايه؟ ريأكسجينيت للهيموجلوبين وايه؟
It's reoxidation to the lactate, reoxidation of hemoglobin, عشان تعملي oxyhemoglobin تاني, and to meet the high metabolic rate of the rest of the organs.
So energy release امتى؟
ايه؟
energy release امتى في الهيموجلوبين؟ ولا مفيش energy release؟
ATP from glycolysis, that's it. Okay, you are going through those pathways just to provide to regenerate the oxidized NAD, so that glycolysis can continue. Otherwise, glycolysis will also stop. If you don't regenerate the oxidized NAD, even glycolysis will stop. Even those two ATP molecules will not be available. And that's why under anaerobic conditions, the cells are going to utilize more glucose than under aerobic conditions. And under anaerobic conditions, one glucose molecule allows only 2 ATP molecules to be formed. Under aerobic conditions, it's around 32 ATP molecules per 1 molecule of glucose. But in order to maintain cell vitality under anaerobic conditions, the cell is going to utilize more glucose than under aerobic conditions. Okay? Understand? So the respiratory substrate is the substrate molecule which is going to be used in respiration. That's what we call the respiratory substrate. Most of the cells can use either carbohydrates, glucose as a respiratory substrate, lipids, or proteins. But the most common used is glucose, carbohydrates, followed by fats. As animals, as mammals, we don't use proteins as a respiratory substrate unless in cases of starvation. Okay? And as we mentioned last lesson, the more hydrogen in the molecule, the more energy value of the molecule. The higher it has an energy density. That's why lipids have a higher energy density than carbohydrates, because the lipids have a very long hydrocarbon chain, but they are going to make more reduced NADs and fats in the Krebs cycle. And that's why they will have a higher proton gradient, they will have more electrons for the flow of the ETC, that's why they're going to make more ATP at the end by chemosmosis. Okay? A respiratory potent is a ratio between the volume of carbon dioxide produced over volume of oxygen used per unit time. That's the respiratory potent. And we can either use it by a volume, or if we have a chemical equation, a balanced chemical equation, it's the number of molecules of carbon dioxide produced over the number of molecules of oxygen produced. For example, aerobic respiration of glucose, C6H12O6 plus 6O2 gives 6 CO2, 6 water, and the ATP. But if I want to calculate the respiratory potent, it's 6 carbon dioxide over 6 oxygen. It's equal to 1. So respiratory potent of glucose under aerobic respiration is 1. Okay? What's the aim of the respiratory potent? Why do we calculate this value? What does it mean? Respiratory potent is going to give us an idea about two things. The first thing, which respiratory substrate is being used in respiration by the cell. If the cell is using carbohydrates, the respiratory potent is 1. If the cell is using lipids, the respiratory potent is 0.7. If it's using proteins, the respiratory potent is 0.9. You memorize those numbers. The value of the respiratory potent will show which respiratory substrate is being used by the cell. The second thing is going to show whether the cell is carrying out aerobic or anaerobic respiration. A value less or equal to 1 is aerobic respiration. Anaerobic respiration, the respiratory potent will be more than 1. So if the value of the respiratory potent is more than 1, this means that these cells have switched onto anaerobic respiration. Okay? لو هي anaerobic respiration full stop, مفيش aerobic mill أصلاً, it will not be calculated because the volume of oxygen is going to be 0.
Okay.
لو أي cell بتعمل anaerobic respiration only, and it didn't respire aerobically, the volume of oxygen is 0. So any value over 0 is infinity. Plus, if it's lactate pathway, مفيش carbon dioxide أصلاً كمان. If the cells are only carrying out anaerobic respiration only and only, you will not be able to calculate the respiratory potent. This does never happen. And always the cell will respire aerobically, and when oxygen is in short, they will switch to anaerobic. فدايما هتلاقوا الvalue is 1 point something. يعني مش هتلاقوا الvalue, يعني الvalue will be greater than 1 point something, because the cells will be respiring aerobically, then they will start to switch to anaerobic when the oxygen is not available. Okay? Understand?
Yes.
مش هتعمل لها لأن أنت the greatest value of the RQ is when you are using carbohydrates in aerobic respiration. Respiratory potent factor 1. Lipids with proteins, the respiratory potent is less than 1. كل دول aerobic. If it's above 1, يبقى هي switch to anaerobic. ماشي؟ اوكي؟
هو انا عليا اعرف ليه الارقام اللي اتقال هنا اللي هي CHO هتوعد
ما هو انت الكربوهيدرات is 1 because the volume of carbon dioxide produced is equal to oxygen used. لما هتقل عن ال1 معناها ايه؟ ان you are using more oxygen. فانت lipids you use more oxygen to oxidize them. That's than the carbon dioxide produced. That's why it's less than 1. عشان كده respiratory potent بيقل عن 1 هنا. It's 0 point something because it's using more oxygen.
هو في العادي انا بستخدم both carbohydrates وليبيدز مثلا بس العادي respiration عادي.
Usually, if the cells have carbohydrates, they will use the carbohydrates. If they can't find the carbohydrates, they will start using lipids. Like in most common respiratory substrates used by most of the cells are carbohydrates. Usually not, rarely. It will depend upon the question you will have. Okay? ممكن تكون مثلا بتعمل lipids and then it starts to switch on to carbohydrates. Depends على حسب الكويشن اللي هتجيب. A respirometer is an apparatus used to measure the rate of respiration, or to measure the volume of oxygen used during respiration, or to calculate the RQ. It's an apparatus that can be used for many different reasons. It can be used for in many ways. A respirometer, simple respirometer, is a test tube, and in this test tube we have a wire mesh which contains a carbon dioxide absorbent, which is usually soda-lime. Soda-lime, this absorbs carbon dioxide, and this test tube is tightly sealed. It has a capillary tube, and the capillary tube is going to be connected to a manometer fluid. لا خلينا بس كنا بنرسمها بالعربي. كنا بنرسمها كده. نرسمها بالعربي بدل ما نشوف. يتحط عليكم بقى في اليوتيوب يرسمها باليوتيوب. Okay, and there's a scale. Next to this manometer fluid. Okay? And we place the living organism inside the test tube, a known mass of the living organism. For example, I'm going to put 1 gram of larva. 1 gram of larva. Okay? How does this respirometer works? The soda lime is going to absorb carbon dioxide. Usually, when we set any apparatus, after I set this apparatus, I have to wait for 5 minutes. This 5 minutes, we call them the equilibrization time or adaptation time. This is time given for the living organisms to adapt to the new conditions they are placed in before we start our experiment. After the 5 minutes equilibration time, we start to seal the apparatus, make sure it's airtight sealed, and we make sure that the scale is at the 0. We have to reset the scale to the 0. Or just take wherever the manometer fluid, the level is, and this is going to be our 0. So whenever we're carrying out any experiment, and this is what we're going to repeat this again in paper 5, فطالما احنا بنعملها, I'm going to mention it tomorrow. Whenever we set any apparatus for any investigation, after setting the apparatus and placing the living organism inside, we have to give it time to adapt to the new conditions. This adaptation time is usually 5 minutes. After the adaptation time, we seal the apparatus to make sure it's airtight sealed, and we make sure that the scale is at the 0. Then we start the investigation. Okay? So, the larvae, they are going to absorb oxygen from the air inside the tube to use in respiration. Any carbon dioxide released is going to be absorbed by the soda lime. So the soda lime absorb any carbon dioxide which is already inside the air of the test tube, and any other carbon dioxide released from respiration of the larva will be absorbed by the pseudolime. And the larvae are going to take in oxygen. So what's happening is that the volume of gases inside the tube decrease, and that results in decrease in pressure inside the tube. This decrease in pressure creates like a suction force, and it will pull the manometer fluid upwards. We will find the manometer fluid rising up the capillary tube. Okay? The distance moved by the manometer fluid, which we're going to call X, is equivalent, it's not equal, it's equivalent to the volume of oxygen used in respiration per unit time. Okay, so the more it moves, the larger the distance, it means it's used more oxygen. There is more respiration taking place. Okay, if I want to calculate the volume of oxygen used, it's going to be the distance moved times cross-section area of the capillary tube, pi squared. Now, when I give the volume of oxygen used, you multiply the distance moved by the cross-section area of the capillary tube. Okay, and in this case, the volume of oxygen used is going to be X centimeter cubed per minute. That's the volume of oxygen used under these conditions. This mass under, for example, I have it in a water bath of 25 degrees Celsius. So that's the volume of oxygen used by these living organisms. Okay? Understood? But this is how I can use the respirometer to find the volume of oxygen used or to find the rate of respiration. You can use it at different temperatures. الexaminer ممكن يقول مثلا design an investigation to show the effect of different temperatures on the rate of respiration. We're going to set it with different temperatures. Or to compare respiration between two different living organisms. For example, it can give you larvae and germinating seeds. And he wants you to see which one of them have a higher rate of respiration. So you can use it in many different ways. كلها لها علاقة بالrate of respiration.